Hey, here's a video tutorial to solve problem number 5 and number 10AB from Michelson. The question is asking us to find a graph in the form of a sine bx minus c, or using cosine, for a non-negative value of c, the least non-negative value of c, which just means that we're going to be moving it to the right. And it says that a should be bigger than 0 and b should be bigger than 0. Now, in order to solve these questions, I'm going to need to have in my mind an idea of what the basic sine graph looks like. And the basic sine starts on the middle line, goes up, back down, and then comes back around in 2 pi. The basic cosine has a similar shape, but instead of starting in the middle, it starts on the top of the wave and comes right back to the top of the wave after 2 pi. So first of all, in order to find the value for a, I need to know the amplitude. The amplitude is how far above and below the middle line the graph goes. So that, in this case, is 3. To find the b value, I know that b is 2 pi over p. So the period is just the distance from the beginning to the end of one wave, which in this case is 4. So the b value is 2 pi over 4. We're writing that in factored form. And the c value is the distance that the starting point moved from the y-axis. And the starting point is right on the y-axis, so it didn't move at all. So we can minus 0 in this one. Now, cosine graph has the same amplitude. It has the same period. It's going to have the same b value. And all that changes between a sine and a cosine graph is the c value. So a cosine is supposed to start with the maximum on the y-axis. So the maximum point is supposed to be on the y-axis. It's not. It's moved over to the right some units. So the c value is how far has that moved to the right. So we've got 1, 2, 3, 4. So it has moved 1 unit over to the right. So I have x minus 1. Okay, the next graph. First I find the amplitude, and that's how high above the middle line the graph has gone. So it goes up to 2 and down to negative 2. So the amplitude is 2. And then I find the period from the beginning of the wave to the end of the wave. In this case is 8 minus 2, which is 6. So the b value is 2 pi over 6. Now the c value is how far the beginning point has moved away from the y-axis. Sine is supposed to begin on the middle line going up. So I see that point right here on the middle line heading upwards. So however far that point has moved away from the y-axis, that's my c value. In this case, 2, 3, 4, 5. So x minus 5. Now a cosine graph is the same amplitude as a sine graph, has the same period as a sine graph, but it has a different starting point. Cosine is supposed to start at a maximum point. It's supposed to start with the top point on the y-axis, so I want to know how far has that maximum point moved away from the y-axis. That is my c value for the cosine graph. So this is sine c and cosine. Cosine and sine have different c values. So that's 4, 5, 6. That should be halfway between 5 and 8. Because maximum is always halfway between 2 zeros, or 2 middle crossings. So that would be 13 over 2, or 6.5. Okay, maybe we'll do one more of those, one of the ones at the end. Let's do question number I. Oh, that's not as hard. It has an easier amplitude. Let's do the last one. Okay, so again, first I find the amplitude by finding how high above and below the middle line the graph has gone. Then I find the b value by using the period. So the period is the distance between two maximum points, which is kind of hard to see on this graph. So the period could also be the distance between two zeros times 2, because we need to finish one complete wave. So this would be one period. So from here to here would be half a period. And that distance is from negative pi over 6 to negative 3 pi over 4. Wow, how far is that? I need a common denominator. So 12. So that would be 9 pi over 12 minus 2 pi over 12. So that total distance is 7 pi over 12. And if that is half of the period, that means the full period must be double that, 14 pi over 12. So now I can find out my b value by just doing 2 pi divided by p, which is 2 pi times 12 over 14 pi. So that's 24 over 14, 12 over 7. That was complicated. Okay, now I have to find my c value by finding out how far my beginning point has moved away from the y-axis. So sine is supposed to begin in the middle line, and it's supposed to start by going up. So my c value, my graph has moved left pi over 6. So I could do x plus pi over 6. Except for the question said that my c value has to be positive. It's not allowed to be negative. So I kind of have to extrapolate and realize that this graph is going to continue, and that there's going to be another c value way over here that's positive. So you can have lots of different answers for c that'll give you the same graph. So c could also be negative pi over 6 plus the period, which if I simplify that is 7 pi over 6. So that would be 6 pi over 6. So it could be the number pi. So another answer for this graph would be 2 sine 12 over 7 x minus pi. I'm not really sure about those answers. I might have made a small mistake, so just to check, I'll graph it on my graphing calculator. 2 sine 12 over 7 x plus pi over 6. Let me graph both of them at once. 2 sine 12 over 7 x minus pi. I'll graph the second one just a little bit darker. Make sure I'm in radian mode, and I'll zoom trig number 7. Okay, so that looks like it's about the same shape so far. And the other one is exactly the same. Fantastic. So now there's also a way that I can write this using cosine. It's a little bit easier. So the c value for cosine is the only difference between a sine and a cosine graph. So for cosine, the amplitude stays the same, the period stays the same. It's just my phase shift that's different. So cosine is supposed to start at the maximum point. So I just need to figure out how far has that maximum point moved. Well, it's not very clearly labeled, so again I'm going to have to interpolate that. So I can see from these 4 dots here that if I start here, the maximum is 1/4 of the way through the wave. So I can just take my starting point and add 1/4 of the period. And the period is 7 pi over 6. And that should get me to my maximum point. So I'm trying to make a common denominator here. So 4 pi over 24 and 7 pi over 24. So altogether, that's 3 pi over 24, or pi over 8. And again, I don't really feel confident about that answer, so I'm going to verify with my graphing calculator. 2 cosine 12 over 7 x minus pi over 8. And I'll give it a special ball so that we can see it coming. There it is. Yay! It matches. So there's 3 different graphs that all give you the same picture. 3 different equations. And there's actually infinitely many different equations that you could write. All with the same amplitude, the same period, but different values for c. Now in question 10, it's telling us to use a sine graph. And wanting us to do this in 2 ways. One is if a is bigger than 0. And again, in that case, we're looking at the basic sine, which is transformation of this shape. So that's when a is bigger than 0. And one when a is less than 0. A is less than 0 means that we have something like y equals negative sine x. So when a is less than 0, that's a reflection. So the basic negative sine graph would look like this. So we're going to do it 2 different ways. First, comparing to this graph, and second, comparing to this graph. So again, the first thing that we need to do is find a. And a is how far above and below the graph goes from the middle line. So in this case, we go up 2, down 2. 1 plus 2 is 3. We can find the b value using the period. So the period is the distance from the start to the end of the wave. The period in this case is 10 minus negative 2, 12 units. So b is 2 pi over p. 2 pi over 12 is the same as pi over 6. The c value is how far the starting point has moved away from the y-axis. So sine's supposed to start at the middle going up. I can see that point right here, starting at the middle, going up. So however far that point has moved away from the y-axis, that's my c value. So my c value is 4. And then D is how high the graph has been translated above the x-axis. Normally the middle line's on the x-axis, now it's been translated up 1. So there's my equation with a positive amplitude. Now I could also write that using a negative value for A. It still has a positive amplitude. And every characteristic is going to be the same, because this graph still has the same period. It's still been vertically translated by the same amount. But now, instead of trying to look for where the point that starts on the middle line going up moved, we want to see how far the point that starts on the middle line going down moved away from the y-axis. So for a negative sign, I want to know how far this point moved away. That should be the starting point. So this distance is my C for a negative sign graph. So I can use minus 10. Now note that I could also have used this point here. So another answer would be negative 2 sine pi over 6 x plus 2 plus 1. Because this point is also starting on the middle, going down. So there's so many different answers. And these would all give you the same graph. If you graphed them all in your graphing calculator, you would get this picture for every single one of them. Now we can also do this graph with cosine. And we can do it with a positive cosine or a negative cosine. So for the cosine graph, all the values stay the same. A, B, D, and only C changes. And of course I wrote sine instead of cosine, so we need. Okay, so now all I have to do is compare it to the basic cosine graph. So the basic cosine starts on the top, ends on the top. So I want to know how far did the top point move away from the y-axis. There's the top point. That top point moved away halfway between 4 and 10. So 7. Right at 7. And this one is a negative cosine graph, so we have to compare it to the negative cosine. A basic negative cosine graph starts on the bottom. It's a reflection of the cosine. Ends on the bottom. So I want to see how far away did this bottom starting point move from the y-axis. And that would be my C value for a negative cosine graph. So that I can see the minimum point is at 1. So x minus 1. You graph all 5 of these equations, and you would get the same picture. Okay, if you have any further questions, feel free to send me your questions on Edmodo.